Let us discuss about the programming. Programming. Programming using timer. How we are going to use timer to generate a delay? Let us we discuss. See here, we take an example of 10 millisecond delay to be generated. There are two methods, as we know that. One method is by repeatedly executing an instruction, we are going to generate the delay. Another one method is by using the hardware, there is timer we can use, and by making use of that, we can generate the delay. So how we can generate by using timer? You can start the timer and you have to give the required value so that from that the beginning value till overflow, it is going to generate the required delay. So that we need to know how to give the values so that we are going to get the desired delay. Here we need a 10 millisecond delay. So let us see the how we are going to generate that value, how we are going to get that value, that is 10 millisecond the delay. See here, the clock frequency is 11.0592 megahertz. This is the clock for the timer. So this clock is divided by 12. This clock is divided by 12. So we are going to get the clock time, time period for each clock pulse is 1.085 microsecond. This is a frequency divided by 12. Then that will be the input for the timer, is a clock, and that is this frequency divided by 12. Then we need to calculate the time period, t equal to 1 by f. So we are going to get the time period is 1.085 microsecond. One clock pulse time. So for each this time, one value is going to be incremented in timer. So here, number of counts we are going to generate. The total delay we need to required is 10 millisecond. If you divide that for one clock pulse, this much time required. So how many times it has to count? So we are going to get count equal to the total delay required and the time required for one clock pulse. So we are going to get this number 9216 in decimal. Okay. So the in mode 1, the timer, if you set mode 1, the maximum is 16-bit count, that is 65,536. So it reaches FF, then it will go to 0. So that is the reason we are going to add +1. That is 65,536 minus this count 9216. You will get the decimal 56320. This we need to represent in hexadecimal, that is DC00H. So this last two digits for the lower value 8-bit, and this first two digit is higher value, that is this will be loaded in TH and this will be loaded in TL. Okay, that is TH will be DC, TL will be 00. So we are using timer 0, means we have to use TS0 and TL0. So now let us see, we know what is the value to load to get a 10 millisecond delay. So remaining things is, as you know, the TMOD register is used to configure. We are going to use timer 0 in mode 1, 16-bit mode. That is mode 1 is nothing but a 16-bit mode. So for that, we are going to use the right hand side, as I told you, the TMOD is having to configure both timer 0 and timer 1. Here we are using timer 0, that right side you have to use. That is 0, 1 is the for mode 1. Okay, this is mode 1. Then configure the timer 0 in mode 1. Then we are going to load the corresponding value into the TL0 and TS0. TL0 and TS0 register. TL000, TS0 DC. So now start the timer. Set B, TR0 means start the timer. Timer start its functioning, means count for every clock pulse. It is going to increment the value. The starting will be DC00. The next value will be DC01. For every clock pulse is going to increment. Whenever it reaches FF, it will go to 0, then overflow will occur. So for that, we have to check jump not bit TF0. Means TF0 overflow flag is 0, means it has to wait. So once the overflow occur, this TF flag become 1. Then it will come out of the loop. Then you clear the TR0, the run bit, and then clear the overflow flag. This is how we are going to generate the delay by using timer. Similarly, here for the given square wave generation of 5 kilohertz frequency on P1.0, clock frequency has been given for timer. So we need to generate by using like this formula. As we know that first you have to calculate T on and T off period. So is a clock square wave means both will be same. So 0.1 millisecond delay for high and low. So that is a delay. Like previous case, we are required 10 millisecond, here 0.1 millisecond. So that is divided by this time. We are going to get this value. So similarly, same procedure you have to follow to generate the delay. Similar procedure. So in mode 2, auto reload mode. It is a auto reload mode. So once if you load, need not to load repeatedly. That is the advantage of mode 2. So here we are using mode 2. So every time we are going to complement, means toggle the LED. So whenever overflow occur, then it will going back, jump back again. So you are loading the jump back here once again, because only once you need to load here the value. Every time need not required to load. That is the advantage of mode 2, where LED is connected. So every few millisecond we are going to toggle the LED. The delay generated by the timer. The same in embedded C, same program in embedded C, delay we are generating. So delay we are going to generate with the help of timer here. Same 10 millisecond generate, we are generating delay with the help of timer. See here, the same 10 millisecond generating, and we are using LED to toggle. So this include file reg51.h. So this is a header file, register 51.h header file to be used. So this header file having all these registers has been defined. For example, P2, POR2, and all other registers has been defined. So S bit, this is single bit, LED P2.0. We are giving as a name LED. Then we are declaring delay prototype declaration. Then main here is actually a program is going to start. Then a first LED will be 0, while 1 infinite loop. So we'll make LED 1, LED on, and have to wait delay, then LED 0, and delay you have to repeat this, while 1 it will repeat. So delay here, main aim is delay we are going to generate by using a timer. 0 1, timer 0 in mode 1. Then we are loading the TS0 DC, TL000. Then start the timer. Then you have to wait till TF0 become 1. If TF00 means hold here only. So whenever it become 1, then clear TR0, TF0. So like this delay is going to generate the 10 millisecond delay here. For every 10 millisecond, your LED is going to toggle. Same program, you use the LED. So similar for some other example of 1 millisecond delay generation. So similar method we are using. So we can use as a counter also, as we told the timer can be used as a counter. So here we are using counter 1 in mode 2 to count the pulses and display on TL1. See here, this counter 1 we are using in mode 2. The T mod you have to configure. Then first you have to load TH1 as 0, so that the value will be the incremented value is available at TL1. So TH1 content will move to TL1 whenever you stop. Then set P3.5 means to make this pin as an input. Okay, then set B TR1, start the counter. Then get copy of TL1 every time the count value will be get into A and sent to the port 2. Port 2 will be connected as display. You can see the count value every time. Then jump not TF, it is not overflow, it is not reaches the maximum value, it will go back and repeats. Then once it will become overflow, and once again start from the start the counter operation. This is how we are going to count. At P3.5, the number of inputs objects can be counted, displayed on LED.